Today's class we shall see about the transport layer. So transport layer is a layer wherein you maintain the transmission of data. So basically the data can be multiplexed, demultiplexed. So all that operation takes place in this layer, and basically you have other control algorithms like flow control, congestion control, so that the data is transmitted properly. So the main purpose is that the data should be transmitted without any error. So basically we shall be seeing all these ways in which it is controlled. So basically we have seen about TCP. So it is a point-to-point communication, one sender, one receiver, and it is connection oriented. So it is more reliable than UDP, and it has got congestion control, flow control, so that the data loss is very minimal. So this is the TCP segment structure. As I told you, it has got a format. So the checksum is fixed, the acknowledgement, the data size, all that has a standard format. So when you have acknowledgement, it is to ensure that data loss is minimal. And there are also sequence numbers, because when you send data, you should know in which sequence the data is being communicated. So when the data is reaching on the other side, it should be able to put it in the proper order. So this is how it is. It has to wait till somebody requests for a data. When the data request comes, it has to send, and it has to acknowledge, telling that it has received the data. So these are the scenarios wherein the data acknowledgement, sometimes it's not getting back in that time, it will again resend. So there is a timeout period. So within a particular time, it should have got the acknowledgement. Otherwise, the data might be lost. So these are different scenarios in which it transmits, and there is a flow control also. So this flow control is to ensure that data is not lost, data overflow doesn't happen, the buffer is not full. So it is flow control. Basically we know about water control, so we try to control the flow by making the pipe go at a slower speed. Similarly, here also the flow control is an algorithm which takes care that there is a buffer space. If there is no buffer space, it will not send data. So that is a flow control. And then there is a connection management. So only when it is properly connected, it has to agree on sending data. So this is also done based on the handshaking mode. So there is a two-way and three-way handshake mode. And now last thing is congestion control. So congestion control is very important, because when data is congested, there is a lot of chance that data may be lost. So if you see here, there are two senders and two receivers. So there is one router just got infinite buffers. So what is the reason for the congestion? So if you see here, in this scenario, when you have different rates, and there is only one buffer, one router in between, and so many other senders are getting connected to the same router, there is a possibility of congestion. Now here there is only one router and finite buffers. So again here also we see when there is a timeout, it leads to congestion. So these are just causes of how congestion occurs. So when congestion is like a traffic congestion, that is there is only one space available, but the data is all coming through that. So in that case, there should be a controlled flow. In that case, we can avoid congestion. So we have something called as the transmission rate, which can be automated, and we have different ways in which you can control the rate. So based on the rate which is optimal, so that the losses are less, we can control the transmission. We call it as the we have a case study here where we try to have a available bit rate, and based on the bit rate we try to increase or decrease the congestion level. That is, there is an indication telling that there's going to be a congestion. Based on that, the data transmission is controlled.